some of the problems from the textbook, ESA textbook, Activity 8A. Number 1, during an orienteering competition, a traveller begins by travelling 5 kilometres west, then travels 2 kilometres north, and finally travels 5 kilometres west. Draw a diagram. I always draw a diagram. There's a few people in history who were spectacular at thinking inside the head. You all know of Stephen Hawking, who was very limited in his movement. The rest of us have to draw. So let's have a look at this. Here's our north. During an orienteering competition, a traveller begins by travelling 5 kilometres west. 5 kilometres west. And then travels 2 kilometres north. 2 kilometres north. And then travels 5 kilometres west. East. What distance did she travel? And then second, what was her displacement from the start? So let's look at distance. Distance is the number of kilometres you've actually moved. So she's gone 5, 6, 7, 12. Altogether her distance, she's actually moved through 12 kilometres. Let's not be confused, it's positive 12 kilometres. That's question A. Second B, displacement. Displacement is how far you are from where you started. So if she started from here, how far is she from where she started? 2 kilometres. Distance, the actual amount of meters and kilometers you've actually travelled. Displacement, how far you are from where you started to where you finished in a direct straight line. Question 2, a car is driven 3 kilometres east for 5 minutes. 3 kilometres east for 5 minutes, and then 4 kilometres south. 4 kilometres south for 8 minutes, and finally 3 kilometres west for 2 minutes and 2 minutes. Question A, find the average speed. And B, the average velocity. So average speed is related to distance. The average speed is equal to the total distance that's been travelled, total distance, divided by the time taken. So the total distance is 3 kilometres, plus 4 is 7, plus 3 is 10, so it's gone 10, she's gone 10 kilometres. I presume it's the same drive as the first one. And the amount of time is it took 5, and 8 is 13, and 2 is 15 minutes. So the average speed is clearly 10 kilometres divided by 15 minutes is equal to 2/3 of a kilometre per minute. But we're asked to give the answers in kilometres per hour. So if we can go 2/3 of a kilometre in 1 minute, how far will we go in 60 minutes? Let's multiply by 60 is equal to 40 kilometres per hour. So that's the average speed. Let's look now at average velocity. And remember that velocity is related to displacement. So what is the average velocity is equal to the change in displacement divided by the amount of time. So what's the change in displacement over this amount of time? Started out here, ended up here. That's a displacement of 4 kilometres. and the time taken is 5, 13, 15 minutes, 14 kilometres in 15 minutes, which is equal to 0.267 kilometres per minute. If it's in 1 minute, how far we've gone of 16 minutes multiplied by 60 is equal to 16 kilometres per hour. But what's the direction? Starting out from this point, ending up here, the displacement clearly is to the south. So it's 16 kilometres per hour south. Our velocity is a vector requiring a size and a direction. Number 3, an airplane undergoes a change of velocity. What must happen in terms of the plane's speed and or direction in flight? So we've got an airplane, a beautiful airplane. It's travelling along and it has a change of velocity. Velocity is a vector. In order to have a change of velocity, it must have either a change of velocity, a change of actual speed in meters per second, whatever, or a change in direction. Got to have a change in direction. So a plane can be travelling at 600 kilometers per hour in this direction. It turns a corner, and now travelling at 600 kilometers per hour in this direction. That's a change of velocity. Okay. Number 4, how much time does it take to travel from a position of -25 to a position of 100 meters at an average speed of 15 meters per second? Something started out at -25 meters and ends up at 100 meters. How long does it take? Time if it's traveling at 15 meters per second. Remember our equation. Velocity is equal to change in displacement over time taken. Let's rearrange that equation and we can have that time is equal to time, multiply both sides by time, divide both sides. That is the distance divided by the average velocity. So time is equal to the distance. Now the distance is 25 plus 100, 125 divided by the time 15, by the average velocity 15 meters per second. So the time is equal to 8.3 seconds. Don't forget units. Don't forget units. Don't forget units. Number 5, a ball is accelerated uniformly from rest along a straight line at a speed of 8 meters per second in 2 seconds. Got a ball. It's started uniformly from rest, so its initial velocity is equal to 0 along a straight line to a speed of 8 meters per second. So by the time it gets to here, it's going at 8 meters per second, and it takes 2 seconds. So acceleration, how long acceleration, determine the ball's acceleration. Acceleration is equal to the change in velocity divided by the time taken. The change of velocity goes from 0 to 8, so the change of velocity is 8 meters per second, and the time taken is 2 seconds. So the acceleration is equal to 4 meters per second squared. And again, don't forget the unit. 5b says explain why the phrase along a straight line is used in this question. Why a straight line? And the answer is so that we know that the velocity, while it's changing from 0 to 8 meters per second, is in the same direction, so that when we do our change of velocity, we don't need to consider its vector. Number 6. If the time required to accelerate an object from rest to a speed of 4 meters per second decreases, explain what happens to the acceleration of the object. Let's write our acceleration is equal to the change in velocity divided by the time taken, the change in time. So, if the time required to accelerate the object from rest to 4 meters per second decreases, what happens to acceleration? If the time gets less, the acceleration gets more. So if our velocity is 4 meters per second, and say the time taken is 10 seconds, then the acceleration is 0.4 meters per second squared. What happens if the time gets less, the time decreases? For example, it goes down to 5 seconds. 4 meters per second divided by 5 is equal to 0.8 meters per second squared, and we can see the acceleration increases. When the denominator gets smaller, the fraction gets bigger. So when the time gets smaller, the acceleration increase. Okay, number 7. How much time does it take for an object to change velocity from -3 meters per second to 5 meters per second when the object's acceleration is 16 meters per second squared? So let's write our equation. Acceleration is equal to change in velocity divided by the time taken. The change in velocity is from -3 up to 5, so that's a change of 8 meters per second. And the time, the time is, we don't know. Acceleration is equal to 16 meters per second squared. So let's rearrange our equation, and we get the change of time is equal to 8 meters per second divided by 16 meters per second squared. The time is equal to 0.50 seconds. Question 8. A cricket ball velocity changes from 33 meters per second to -27 meters per second when it's hit directly back towards the bowler. If the ball is in contact with the bat for 0.0050 seconds, calculate the ball's average acceleration while it's being hit and give its direction. So we want to find the average acceleration, and that's going to be a change of velocity divided by the time taken. Now, I like this kind of question because it's a real one, and ask yourself, what kind of acceleration do you think you can actually make on an object? What acceleration do you think you can reach? And let's have a look at this real world situation. We've got a cricket ball with a little cricket ball travelling towards the bat from the bowler at 33 meters per second. The batter strikes it and it returns back the way it came at 27 meters per second. Now, when we have questions like this, the thing that we've most got to keep in mind really is direction, which is positive and which is negative. So I'm going to say this cricket ball is going 33 meters per second in a positive direction initially, so that means we'll say this velocity is 33 meters per second. After it's hit the bat, it's travelling in the negative direction, going this way, so this has got to be a velocity of -27 meters per second. So initial velocity is positive 33 meters per second. Final velocity is equal to -27 meters per second. Okay, now let's go back then to look at how we need to know the change of velocity and the time. Our equation for change of velocity, remember, change of velocity is equal to V final minus V initial. final velocity is negative 27 meters per second minus the initial velocity of 33. The change of velocity then is negative 60 meters per second. That's why we needed to make sure from the very beginning that we had decided which way was positive and which way was negative. That's 33 meters per second positive velocity, negative 27 meters per second that way. So the change of velocity is 60 meters, negative 60 meters per second. That means the change of velocity is in that direction. And that makes sense, doesn't it? It goes from 33 this way to 27 that way. The difference is 60. We just need to bear in mind our direction. So now we've got our change of velocity is negative 60 meters per second, and the time it takes is the time it takes for the velocity to change. That's the time that the cricket ball's in contact with the bat is equal to 0.0050 seconds. So let's come back to our equation. Average acceleration, change of velocity over change of time is equal to negative 60 divided by 0.0050 equals 12,000 meters per second squared. What acceleration do you think you can provide? Negative 12,000 meters per second. Because it's negative, that means the acceleration must be in this direction, which makes sense. The ball was travelling towards the right and now it's travelling towards the left, so we're speeding up this direction, slowing it down, speeding it up, so the acceleration's got to be in that direction. So again, that's one of my favourite problems to solve. Later on we'll look at one where the ball bounces off an angle and we'll have to do a vector subtraction, but otherwise it's pretty much the same.